All right, in this video, we are going to do lesson 6.3, which is using the elimination method to solve systems of equations. So let's jump right into example 1. There are step-by-step directions right up here, but I don't think you will need those if you just follow my example below. All right, so basically what you want to think of is traditional addition. We want to be able to like add the columns, if you want to say. So like 4x and 3x makes 7x. And the goal here is to be able to cancel out a variable term. So because if you add 6y and negative 6y, they go away. And then now we do 32 plus 3 to get 35. And now you have an equation with one variable that you can just divide by 7 and get your final answer. So then from there, you will choose one of the equations. It doesn't matter which one. And you will substitute it in. So if we choose this equation, we have to plug the 5 in for the spot right here because this is where the x value of 5 is going to equal. That didn't really make sense grammatically, but basically what I was trying to say is don't plug what x equals in for the y spot. So do you see what I did here? So now we solve for y. So we have a 20 here. So if I subtract 20 from both sides, you get 6y equals 12. Divide by 6, and y would equal 2. So don't forget to write your final answer as an ordered pair of 5, 2. So don't forget always the x values first, then the y value. So you have 2 guided practice problems here to do. You can pause this video right now and try them, or if you want to see another example, just stay here and do this one with me. So because this negative 4x and 4x are going to cancel out when we add them together, we're going to use addition because coming up in the next example, you'll see some subtraction ones. So right now we're doing 3y plus negative 5y, which gives us negative 2y. And negative 3 plus 5 is positive 2. Divide by negative 2 and you get negative 1. So then from here, because y equals negative 1, I can choose either equation. I'm actually going to choose this one here to substitute negative 1 in for y because this is a positive 4x at the beginning, and that just makes it a little simpler. So if I'm plugging negative 1 in, I'd put it right here, and I would do 4x minus 5 times negative 1 equals 5, and I want to solve for x. Now keep in mind this gives me a positive 5. So from here, subtract 5 from both sides. You get 4x equals 0, divide by 4, and you still get a 0. So your final answer here is 0, negative 1. Moving on to this next one, there's something I want you to notice here. The columns do not line up. And what I mean by that is this is a different variable and these are opposite variables. So basically what you have to do is pay close attention. It's not always going to be perfectly set up, and reorder them. So if I would keep the top equation the same, I would make the bottom equation have the negative 4y, then a positive 3x equals 14. Now, when I go to add these together, it's going to cancel out these because they have opposite signs and give us a 6x here. So pay close attention to the sign in front of the coefficient of the number. So the coefficient is the 3 or the 4 or negative 4. So I'm adding these together, which will give me 36. Divide by 6 and x would equal 6. When I plug these in, it really doesn't matter which equation. I'm going to just go with this top one and plug the 6 in here. to solve for y. So then that's going to give me 18. So if I subtract 18 from 22, that's going to give me 4y equals 4. Divide by 4 and you get 1. So my final answer is 6, 1. Okay, so before we jump into elimination with subtraction that we're going to do in example 3, let's do a word problem. So it says -3 times one number. We don't know what that number is, so we can use an x, plus 5 times another number. So because it says another number, we can't use the same variable that we just did. So how about we use a y, and it is equal to 11. So the word is just means equals. So that's one of our equations. Let's write it down here. -3x plus 5y equals -11. So our second equation is going to be 3 times the first number. So the first number you used was this x variable to represent that unknown, plus 7 times the other number, which you used a y for it, is -1. So 3x plus 7y equals -1. Find the two numbers. So we are going to add them together. Which cancels out that right there. And 7 plus 5 is going to give us 12y. And then -11 plus -1 is -12. So divide by 12 and you get -1. So -1 is your first number. Go ahead and substitute that back into either equation. I'm going to plug it into this bottom one just because those numbers are ones that I like better. It does not matter which ones you choose. So from there, solve for x by doing 3x plus 7 times -1 equals -1. So that equals -7, which means I add 7 to the other side to cancel it out. And 3x equals, really this is saying 7 minus 1 to get 6. So x equals 2. Okay, so you might just want to say, like, because it's not really saying an ordered pair, it didn't give you the variables, you might just want to say the two numbers by saying -1 and 2, like that. You don't really need an ordered pair since it's not specifically using x and y. So what I'd recommend doing is pausing this and watching the guided practice after you give it a try on your own first. Okay, so the sum of two numbers is -10. So you can just say that x and y are your two variables you're using. So that's your first equation. The second equation is a little more complicated. So -3 times the first number minus the second number equals 2. Okay, so -3x minus y equals 2. So when I add these together, the variable that's going to cancel out are these because they have opposite signs. So -2x equals -8, so x equals 4 when you divide by -2. I'm going to plug the 4 into this equation to get my second number. So 4 plus something gives me -10. So subtract 4 from both sides. So y would equal -14. So your two numbers are 4 and -14. All right, so the other way that we can use elimination is by subtracting the two together. So the reason we want to use subtraction sometimes is they will have the same coefficient of 8, but they're the same sign. So if we added them together, that would give us a 16b. So instead, we subtract. So the one thing that I always notice is the biggest mistake is we forget to then subtract the rest of the numbers. So you want to do 3 minus 7 to get negative 4, C. And then 11 minus 7 to get 4. One way to avoid forgetting that you need to subtract all the rest is sometimes just distributing. And then that way you can do, basically it's keep, change, and then change all the rest. Okay, that might help you. So then that way you remember whatever sign is kind of here is the math operation that you're doing with them. All right, so just to finish solving for C, we're going to get a negative 1. And when I plug that back in, it doesn't matter what equation, so I'm just going to choose the top one. So 8b plus 3 times negative 1 is going to give us 11. So that equals negative 3 when we multiply. So I add a 3 to the other side. And 8b is going to equal 14. So because this does not divide evenly, sometimes that will throw up a red flag. So 14/8 does reduce to, I'm going to divide them in half, so that'd be 7/4. So because it doesn't divide evenly, I'm a little worried that maybe I did something wrong. So let me show you how to check your answers. All right, so we are saying that B is 7/4. So I'm going to substitute B into there, and we're saying C is negative 1. Okay, so if I'm going to check to see if this is true, I can make this a fraction and cross cancel. And that gives me 14. And then minus 3, which equals 11. Okay, so that checks. But in order for it to be a solution to both of them, you technically have to check the other equation here. So if I plug B into there, I get, actually we can kind of cheat a little bit because wasn't it the same? So I should get a 14 then when I multiply them. And then it's plus 7 times the C value, which we said was negative 1. And when we do that, it should equal 7. Well, then when we multiply this, we get a negative 7, and that does equal 7. So we can be confident in our answer when we check it because we know that B is 7/4 and C is negative 1 since we checked. Now, because these weren't an X and a Y, you go with the ordered pair, putting the one that comes first in the alphabet, then the one that would come next in the alphabet. So it's alphabetical order every single time for ordered pairs, even when they are not an X and a Y. So what I would recommend doing is pausing this to try the guided practice. And hopefully you've got a chance to try it now and you're ready to check your answer. One thing to be cautious of is I'm going to reorder this bottom equation so the columns match up to have everything in the right order. So my T's are in the same column. And I'm going to have to use subtraction because I want these to cancel out. And 5 minus 9 is negative 4r. And 6 minus 22. Okay, so that's really 22 minus 6. So that's 12 minus 6, so 16. But because this one was the opposite order, it'd be negative 16. So from here you would divide by negative 4 and r would equal 4. When plugging it back in, you can choose either one. How about we choose the top one? So 2t plus 5 times 4 equals 6, so that equals 20. Subtract 20 to cancel it out. 2t is going to equal negative 14. Divide by 2 to get a negative 7. Okay, in alphabetical order, A, B, C, D, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T. So R comes first in the alphabet, and then T comes after R in the alphabet. So that would be your final answer. All right, to finish up this lesson, let's do a word problem here. So it says Anna and Elsa work in an ice cream shop. Anna earns $8.50 an hour and Elsa earns $7.50 an hour. During a typical work week, Anna and Elsa earn $299.50 together. 1 week, One week, Elsa doubles her work hours, and together they now earn $412. How many hours do they each work during a typical week? Okay, so I made a table here. I don't know if I would always emphasize putting a table down to organize your information because it doesn't always work perfectly like this. So what you want to do is make an equation about a typical week and about the other week, because that is the two things you're comparing. So you kind of have a theme for each equation. So Anna's pay is $8.50 in a typical week, and Elsa's pay is $7.50. Okay, and if we want to say like an Anna and an Elsa, because if you put a variable behind it, that would represent the number of hours Anna works and the number of hours that Elsa works for each variable. And if we add them together, it said that during a typical week, they earn $299.50. And just to reiterate, the question said how many hours do they each work? So that's why our variables are representing how many hours they each work, because your question is always what your variable is going to represent. Okay, so during that other week, Elsa's going to double her work hours. So that means we need to look at our table, and Elsa's going to make the exact same hourly wage, but her work hours double. So we can multiply them by a 2. Anna's pay is still the same, and she works the same amount of hours. And now together they're earning $412. So now that you have both equations written, you want to decide which method you want to use with elimination. And when I look at this, the 850A is the same sign, so that means I'd have to subtract in order to cancel those out. So if I subtract those, that goes away. Okay. So when you do this subtraction here, 750E minus 2 of 750E's, because really you could rewrite this like 750 is the number you're multiplying, like you have 2 of them here. So really this is going to be negative 750 because that's how much you're going to have left. Another way to do it is just say 2 times 750, well 2 times 7 is 14, 2 times 50 cents is $1, so that's 15. So if you wanted to do 750 minus 15, that would explain a little bit more about why we have negative 750E. And then $299.50 minus $412 is going to be negative $112.50. From here, you would divide by negative $7.50, and you'd get 15 hours. So Elsa is going to work 15 hours. So if I plug in, I'm going to do it back up here. It's going to get a little messy. So if I substitute 15 back in there for E, I would be solving for A. And that's going to equal $112.50 that she's contributing. Solving for A, that means I have to subtract 112 to the other side to give us 850. A equals 187. Divide by 850 and you get 22. So that's 22 hours that Anna works in a typical week. So make sure for your label that you put hours and maybe even explain that this is Elsa and that this one is Anna. You could even write it out in a sentence to be very clear that during a typical week, Elsa works, and hers was 15. And Anna works 22 hours. Okay, so that would probably be the best way to write your final answer because it's very clear about what you're asking for. And if you look back to see if you answered the question they were asking, it says how many hours do they each work during a typical week. You're very confident in how you gave your answer because it literally says during a typical week. All right, so the next one in the guided practice is a little different. So if you want to do it with me without pausing it, that's fine too. So it says here that Mike and Sully are throwing a birthday party for their friend, and Mike invited 5 fewer guests than Sully. So this part sometimes confuses me on how to write the equation. So Sully and Mike, if we set them equal to each other like that, that's saying they invited the same amount of guests. Okay, but Mike invited 5 fewer. Typically, and I've done this problem and accidentally did it like this with the 5 on that side because Mike invited 5 fewer than Sully. But if we want them to balance out with each other, you want the 5 here because Sully invited more people. So think about this. Sully invited more people. We take away 5 from Sully, and that's going to give us how many Mike actually invited. So this is the proper way to write it. And then the second equation says together they invited 47 guests. So that one's a little bit simpler. The number of guests Sully invited plus the number of guests Mike invited is 47. From here, I would actually recommend not using elimination, and that's fine if you're showing me a different method, as long as it makes sense, okay? Because the way the equation is written, m is already by itself. Wouldn't that be nice and easy just to plug right in here? So s plus, and then the s minus 5 equals 47. So then 2s minus 5 equals 47. Add the 5 to the other side. 2s is going to equal 52. So the number of guests Sully invited when we divide by 2 gets us 26. So because Mike invited 5 fewer, we just would technically plug this back in here, and s minus 5 is 21. So that's saying that Mike invited 21. So let's check. Does 21 plus 26 equal 47? It does. And Mike invited 5 fewer, so Mike should have less people, does he? Yep. So let's write it as a sentence for our final answer, that Mike invited 21 guests and Sully invited 26 guests. Okay. So for your homework, I don't think there's any that are set up like this for substitution. But if it is, you can feel free to use other methods. Otherwise, in your homework, I want to make sure that you are doing the elimination method the entire time. Don't graph them. Don't use substitution unless it's perfectly given to you in, say, slope-intercept form for graphing, or like the guided practices where a variable is already by itself for substitution.